I think this is the first algorithm of data mining. Has been developed for long. This association rule mining technique has been considered and developed late 1990s. Oh no, late 1980s. Early 1990s. That time also I developed my own data mining tools. This technique has been published in one conference paper, and my work was published at the journal paper IEEE Transactions. So you can see, right? I'm the first generation of this. So yeah, another thing that I want to make sure that I do not want to teach you garbages, easy to understand, so a little bit challenging. If you think, oh, I fully understand today's lecture, which means all the garbages. So little challenges. On your way back home, I need to catch up this, I need to catch up that, and that, and that. A lot of things are unclear to you, then that is your. I know that's hectic to you, but this is a graduate course, and you spend a lot of time and money. So at least you need to learn something good, okay? Not the garbages that you learn somewhere, or you can understand quickly by reading books and papers, not like magazine level of algorithms, okay? I am also currently developing the work that I am presenting today. But if you implement something, you may be able to know, oh, there's a lot of things that you have to consider. Okay? There's no such programs that can run all the cases all the time at highest performance. There's always a lot of room that you can improve. Okay, that is the work that I'm going to give you insights. But we need to start from the basic concept. So what we will do today is a chapter 5 from the book. Remember the book? It's not required, but why it is not required? I'm not going to cover from cover to cover of that textbook. I'm going to pick some essence from those textbooks. And once I pick up, then I give you full explanation of that algorithm, and also give you some implementation details. So it keeps me busy, but I like it. But I really hate if I do not have no students who are interested in the level of work that I am delivering. Then it's not good, right? So I know in this classroom, I know somebody who really wants, and not somebody, most of you. Right? So what we will do is I'm going to give you frequent patterns. How can we find the frequent patterns? What is a frequency? Frequency is the number of occurrence, right? Number of occurrence. If you find the pattern, then we always think how often that pattern occurs. So we need to analyze that. Frequent pattern is a pattern that occurs frequently in a data set. If you stick to the frequent patterns and locally finding a good data mining outcomes, then that will be a great resource that you can reuse it. Okay? For example, you set up a network infrastructure, and definitely if it is open to the public, there are a lot of attacks, okay? Intrusive attempts all over the world, all over the world. So you can take a look at some log files, and then there is a IP address so that you may be able to see where the last point that attack come from. Okay. And also they wants to grab some powerful process from your infrastructure. So you can analyze it very quickly. And also you can see the frequency of that intrusive attacks. By looking at that frequent patterns, attack patterns, then you can see attacks from some specific locations and some limited time frame in order to catch a specific process. So by knowing all of those, and those patterns occurs very frequently, if you are lucky, then you can find periodically, not just frequently, but periodically. Hey, this guy comes in my system, try to come to my system 2 to 3 o'clock, Monday through Friday. That attackers also take rest weekends in order to rebuff their muscles and come back Monday morning and pretty smoothly. So, if there is a frequent, if there is a periodical patterns, then you can reuse it to monitor next time when it comes to that events or attacks. You can watch, right? That type of patterns will become very useful, very interesting, right? First, a proposal by Agrawal and Swami when they were IBM Research Center, West Coast, All-Modern Research Center. In 1993. Motivating to find the regularities in data, more frequent regularities in data, is this. What products were often purchased together? So a typical example was beer and diapers together. Without knowing this, if you think beer and diaper, they are not really related. When you purchase beers and diapers, it's not really commonly, usually relevant items. But those are purchased together at the specific location. At the specific location and at the specific time. Anyone here married and raise kids, have some experience buying beers and diapers together. But what is the pattern for that? It's not really related, right? But if I tell you the location and time, then you quickly understand. Oh, yeah, that makes sense. Okay. I want you to consider somewhere in the Midwest. If you go to Iowa, for example, then it's all cornfield, right? The cities closest cities to, for example, Iowa, Ames, outside Iowa, it's like a 5-hour drive away or 6-hour drive. So if you drive 70 miles on the highway, you don't see any big cities, only cornfields. So your home is somewhere like an hour away from Ames, Iowa. Okay. Anybody here been in Ames, Iowa? So you don't imagine, right? But think about some movies and. But you know the life, right? A rural life. And Ames, for example, it's not really a big city. It's not. We are in the biggest city. Not really the biggest city in the world. This guy come from the biggest city, right? No, not really big. Close to biggest. It's from Shanghai. Where are you from? Oh yeah, you are China. Taipei? So, anybody here from some other bigger metropolitan? Okay. Maybe Binghamton is, Binghamton is a good example, right? Binghamton is a pretty good size, like about 100,000 population, or not more than that. Because almost all are university employees and students. During summer break, population will drop half. And fall, maximum and spring semester a little lower. Some students drop out or transferred, something like that. And somebody lives somewhere, some other cities, like our drive from Binghamton, right? So Friday afternoon, after work, so his wife or her husband asks to bring groceries. So guys stop by the groceries and he has to plan, near my home there is no groceries, there is no big retail stores, so I need to worry about my wife, I need to worry about my friends. So every time weekends they have big barbecue parties, right, usually. So, I need beers. And, I have my daughter or son, he's still toddler, so I need to grab some diapers. So they never forget to buy diapers and beers together. They means those who live a little away from pretty good size of the town and having a small kids. And always plan barbecue parties, backyard, weekend. So this is the time that we have to prepare. Then their basket, if you look at their basket, and they never forget both of those two. So without having that specific conditions, then they are not related. But under that, they are related. Therefore, those two are very, very closely related. So what happens? What is the benefit benefit from the fact knowing about that? What is the benefit so that somebody may be able to use it? Who? Advertisement, maybe, right? Or there's a stock Somebody who stocks the items on the grocery stores. What is the name of those guys?
Grocery?
The merchandiser.
Huh?
Called merchandisers.
Merchandisers? Somebody who manages the stocks of stock items. So what that guy would do, they want to put them in the same shelf. Beers and diapers. When? Friday. And Sunday through Thursday, they don't need to put them together. But particularly Monday or Saturdays, they put them together so the shoppers can pick them up so quickly, and then they can leave quick.
I've actually seen that, like on Reddit, in in a funny subreddit, they would have like a picture with like beer and diapers, wine and diapers, or
right.
some sort of alcohol and baby stuff.
Mm-hmm.
People thought it was really funny. That makes sense.
So what is the motivation of data mining? Motivation of data mining is that we want to find something which is never known before, and something that is very, very interesting because we never known before, and something that is very, very useful in some application domain, like stock management needs to know that, right? Better to know that patterns. There are a lot of such examples available. Another critical example, you may need to go to bed. Me too. Edmund. There is some situation, like for example, medicine example. Medicines, for example, medical doctor, they need to diagnose by hearing the patient's explanation. Usually, they use their some expertises, right? Expertise they previously known. So some doctors has better reputation than the other because better reputation people can give more accurate diagnosis. But if you have data mining tools, and if you have data mining tools requires big data. If you have a small data sets, and then find some patterns from there, then it may be good to that small specific data sets. It may not be useful to others. So best way that we can say, oh, this is a good patterns that we discovered from our data mining, then you should consider as big as the data that we have. Then it can cover all the situations. Supposedly, I want to consider that a big hospital has patient symptoms and treatment data for last 20 years or 30 years. So it is big data. So there is a matches, symptoms and treatment. And later, so new patient comes, and we know that this guy has the symptoms which is similar to the symptoms that we fixed previously. Okay? Then we can simply use the treatment. If there are multiple different treatments, then we need to make sure that which ones, right? But if there is no such linkages, what happens? There's a brand new. So there's a symptoms discovered newly. Then you need to search. You need to consider all other symptoms and treatments one by one, one-to-one, to see if there is some interesting matches available. So similar to that, second bullet, what are the subsequent purchases after buying a PC? Somebody buy a PC, then usually they can buy printers and some of the storages, and that is also something that we can find. But that type of knowledge, that type of patterns, is we already know, right? We can reason about it very quickly. There's not big benefit from our data mining. There should be something interesting, which means never known before. I do not know what, but in specific situation, when a PC is purchased, then there may be something other also. I do not know what. Right? We do not have a clear, interesting matches to that. Another thing is what DNA and drug. Some types of DNA may cause some diseases. To fix that diseases, some drug, medicine needs to be applied. So there is a cause and effect chains available. We may be able to find it. Currently, something that we do not have, but I suspect that there may be something good cause and effect chains available in medicine and drugs. It cannot be proved by pharmaceutical experiments or medical experiments, but by data mining. Somebody had very severe health problems, like a cancer somewhere, right? But he was cured accidentally. Then what happens? We need to find out. He didn't take any specific medical treatment, but cured. Fine. A year later, he has no cancer cells anymore. Then what should we do? We need to find out what kinds of food that he has taken last 1 year. But if we have such data, then it'll be good. But the problem is that there is no such data available, right? These days, I'm wearing a Fitbit, as you may see, right? Fitbit. I don't like Fitbit, so I purchased this a year ago. I never used this. First couple of times I tried it. Oh, there's no particular the pattern that I can capture from wearing this Fitbit. But I recently, my sister said, "Oh, if you wear this, say several months or years, then there may be some patterns, or your sleep patterns. The sleep patterns slip. If you sleep well, then you can avoid a lot of critical diseases, right? And also, if you can add here types of food, not really add here, but your cell phone and this connection, right? So you can add types of food, so they can calculate calories and all such things. So I'm now collecting data. So it should be collected for years and years. Then several years later, then if I see all of my body temperatures and heartbeats and sleep patterns and eating consumption patterns, all such things, then finally we can do some data mining. And also I can test my DNAs. These days DNA Anybody here knows your DNA? Full the DNA information? Evans, do you have DNAs of yours?
Do I have
No.
DNA?
DNA data.
I don't know.
I know you have your cell. Yeah, I can see yours, but real data. Yeah.
Actual data for DNA?
Yeah.
Can I have hospital records?
The cost reduced a lot these days, right? 10 years, 20 years ago, you have to pay $10,000. Now, a couple of $100, then they can give you DNA information, each individual. So you can apply that DNA information, or if you can buy DNA information with the patient historical data, so that you can match, oh, this kind of patient has that kind of diseases and eventually cured or quickly died, or there's some immune systems can be found. So that is a very, very important topic. Can we automatically classify web documents? Wow. If I have time later or some other time, I developed a simple Python programs. So starting from, you can enter any website address. Any website contains one or more HTML documents, right? And then each document, if it is not dangling documents, if it is not isolated, then one document connects to other documents by having, those who knows HTML knows this, anchor, right? There's an anchor tab so that can connect to others. So what you can do is scan through all the documents and then capture the anchor information, and then there is HTTP, and grab that URL and visit that web page, and then scan through that web page again. There, in turn, another forwarding URLs, so they can traverse further and further and further all the way. So I ran mine year and a half ago. I implemented that 2 years ago. It ran about 3 hours, and then finally my memory is full. Because currently my system does not save the files, but everything is on the memory. So memory is full, so it just stopped. But the program itself can run forever. Initially, I need to improve that program. It is nothing but the web crawler. So my Python program crawls over the web page to web pages, from web page to web page. Okay, and then there is this because it scans, it grabs some keyword, searches some keyword that I am looking for. So a year and a half ago, when I tested some keyword, very sensitive keyword, say terrorism. I searched through. There are a lot of web pages, okay, which I've never known before, because it is connected from www.mercy.edu. From www.mercy.edu, then there is a Blackboard linked, and there is some other sports web pages, and go there, for example, Fox Sports, and then there's some other linkages. And then it goes to CNN. And CNN has, once you get in CNN, there's a lot of linkages, right? So, in theory, you can search all the web pages in the world once you run it. Okay? Only minor problem, if you try to do that, minor problem was that there is some like a coding issues. Character. Some characters in Unicode, some characters simply 8-bit ASCII code, like English. Some uses 7-bit ASCII code. Some uses 8-bit code. And each country has a little different coding systems. Therefore, when it comes to that website, doesn't capture and hang in there. So that is the only problem. But in programs, you can clean them out very nicely. So you need to, like UTF-8 coding system can use to. That is only for the display, because you need to see the monitor, right? So display purpose. If it is not, then it cannot display on your program itself. It's not web-based, but your program-based. Applications. Basket. So this particular example, beer and diaper, so use for typically it is called the basket data analysis. Okay. Each retail stores has baskets. So each basket has basket is nothing but transaction, right? After this paper was published, there are a lot of related paper. Oh yeah.
Would you say basket is
basket? This basket. Grocery basket. Not.
No, I didn't know if it was like a technical.
No, it's grocery baskets. Yeah. So a little technical term was we call that transactions, transaction set. So one basket is nothing but a transaction. So each transaction consists of data items. Okay, diapers, beers. Another related data mining papers and techniques developed was how many diapers and how many beers. That is a very, very important information to retail store managers, right? We cannot consider the following two shoppers equally. Shopper one pick one pack of beer and one pack of diaper. Another shoppers pick 3 packs of beers for weekend and 5 diapers. We cannot treat them equally, right? That has been also considered. Another examples related, extended from that is somebody comes to my store frequently, so there is some sequence. Monday he purchased XYZ. Tuesday he purchased ABC. Wednesday he purchased something else. And then he skip Thursday and Friday. Saturday is something else. So if you see those sequence of transactions, then there may be another interesting patterns. By knowing the sequence, we can predict, oh, this kind of guy, if we have a very, very long historical data, then we can see, oh, 10 years ago, this guy purchased in this pattern. 5 years ago, oh, a little different. And a year ago, again, he shifted. He's tasted from, yes, Stephanie, from one way to another way, right? And also, even for the same shoppers, the items picked by the same shoppers are not the same depending upon the time that the shopper comes in our store, right? In the morning, the same shoppers pick up something else. In the afternoon, pick up something else. At night, 2, 3 o'clock at night, then probably something else, some emergency related items may be picked up, right? So depending upon the time, depending upon the season, for example, or weekly based, or seasonally, or annually, there are all different kinds of patterns, because the patterns are not always the same, may evolve from one pattern to another pattern. If you have a very long historical data, the shopper's item, there's no shopper's items like iPhone or, right, like 30 years ago. There's no iPhone. 30 years later, probably there is no iPhone, maybe something else. 30 years later, if we say, oh, once upon a time there is an iPhone, and through the iPhone we communicate one to another, then 30 years later, generation think, oh, what is it? How come you use phone? For example, right? If we say, oh, at that time we drink Coke and water, how come you drink water? Do you drink like 20 what is it, milliliter bottles every day? You can simply one shot of condensed water, then it lasts a year. Come back next year for your drink. You don't have to drink. Who knows, right? Right, William?
I like to drink, so I don't know.
Oh, you like?
No, not that, but
If you all go to live up in the air, there's no bathrooms. So you have to save space. Because if you... Okay, there's waste. Waste management is a big problem in the future. Then, okay. Alright, so there are all such things. Why is frequent pattern mining important? I mentioned a little bit already, right? Frequent pattern, an intrinsic and important property of data sets, and foundation of many essential data mining tasks. Oh, this is good. So we're going to do a little bit of this in this semester. Association. Ooh, where is my pen? Oh, here. Association. This is the task. This is one of data mining tasks that we are going to work on today, and also next week. By the way, next week we will not meet here. So what I'm going to do one or the other. Either cancel, or I can post my lecture, video lecture, so that you can learn it from home. Or you can come here and some of you together to watch my video. That is fine. So there is no lecture here, okay? But there may be lecture virtually. If I record my lecture, it depends on where we stop today, okay? If I think, oh, this is good to deliver, or, oh, I should meet our students, depending upon that I can do. Either cancel, or video lecture. Video lecture, if it is video lecture, it'll be on the blackboard, so you can see me there. That is next week. And then we will meet the following week also. And then first Wednesday of November, we're not going to meet again. There is cancellation. My class will cancel. First week of November. November or 3rd or 2nd or 3rd. Huh?
I'm definitely going to this all writing because I'm going to forget.
Yeah.
Yes.
So November, November,
Class is canceled. Just
November the 3rd. Is it 3rd or 2nd? 2nd, right. I'm going to be in Kansas City. There will be.
Can you bring back some like ribs and like brisket? And stuff?
Oh yeah, this is so great, delicious ribs, right? Right. Can I leave mine and I can replace over there? Yeah, we have NSA Center Director meeting there. Usually when they host the NSA Director meeting, where there is something. Something means something secret. Anybody knows what is in Kansas City? Stephanie, military guys. You've never known anything in Kansas City? Okay. So we'll see. So today I'm giving lecture. Next week may or may not. Hopefully I can give you. I should, right? Because I definitely I cannot come technically, physically. I cannot do anything that week, first week of November, because I need to be in Kansas City, Kansas City. So association rule is the rule that we are going to look at. So I'm going to give you detailed algorithms, which means by knowing that you can implement it, you can program it, right? Of course, after knowing this, after knowing the algorithm, I want you to do a little bit short on implementations in Python. I'm going to show to you how much I've done. And after that, we'll import some of the modules, Python modules, already developed, so that we can use it to do a little bit of mining, this association rule mining. Okay. So in this module, we'll look at 3 things. So each module will have different, right? Sometimes we use Python and R and some Excel. Oh, I forgot to post the homework assignments. Please remind me.
Oh, shucks.
Yeah,
Right?
leave for a week or 2. We don't care. What homework is that?
Remember the last modules that we did? 4 ways: manually, using Excel, using R, using Python. Right? I think it's a big challenge. I know there are somebody who hates these kinds of all different alternatives, therefore hates me finally. Well, fine. Okay, correlation. You can find the correlation using statistical tools. So typically statistical tools gives you correlated patterns. No statistical tools gives you association. Causality analysis. This is also, there's some theory in math, but usually computer science can do causality analysis. Sequential and structural patterns. Sequential patterns, not really sequential, but somewhere here time series. Yeah, time series. We are going to do this, time series. Or stream data, streaming data. This is very, very important. Anything that these days, if you collect data consistently, continually, then all the data comes in real time, which means streaming data. What is the example? All the medical sensors, the data from medical sensors, this is streaming data. Data from patient continually generates. All sensor data, that is also 24/7 streaming data. So how can you deal with the streaming data? Streaming data with the timestamp, then that is time series data. You have data 1 at time t1, data 2 at time t2, data 3 at time t3. You have always timestamps with the data. Then there's a time series data. That should be taken care of separately, especially, right? That we will do in this time series. And classification, this is the next step. And clustering analysis, that is the last step in this semester. All others, there's so many others possible, but
Professor, just a quick one. Is this done during the collection phase or is it post-collection? So in other words, if you...
they're all post-collection. Once you collect, then make sure that you have... once you collect, then what happens here is that there's a lot of missing data. So you need to decide what to do with the missing data. Are you going to clean them out? What if you clean them out all? Because every single data has missing points. Then cleansing data, outcome of cleansing data is none. What are you going to do then? So cleansing is sometimes needed, but not all the times. Why? Because all kinds, big data, if you construct a big data, then a lot of missing data points here and there, all the time. Then there, you may see, oh, they're all garbages. No, they are not really garbages, as far as you know how to fill in the gap. By knowing other, you can see, oh, I can fill this. By knowing others, I can fill this. Like, it's a lot of puzzle games, right? Initially, a lot of gaps. But as you fill in, at some points, after some points, you feel you suddenly know everything, right? So first a few steps, it's very hard to fill in. For example, another game, TV show, Family Feud. What is that? Is it like puzzle, right? Mm-hmm. Is it title of that TV? Family Feud.
Isn't it like Wheel of Fortune?
Oh yeah, Wheel of Fortune. Yeah, Wheel of, oh, thank you. Wheel of Fortune. Oh, have you been there? Have you been there?
The Wheel of Fortune? I watched
Yeah.
it.
You want to spin it? The vacation. That is the most interesting. Or the money, big money. So, there are a lot of gaps, right, in that puzzle. So, chance comes to somebody who has luck, right? It's not like, oh, I can solve it because I know everything. It's not the case, right? It is the three teams take turns. So somebody's two the other guys fill all significant blanks. So when it comes to my turn, when I see that, I can solve it immediately, right? I didn't do anything up to that point, but because of somebody's help, that is my turn and the money comes to me. Same thing. if you have big data, a lot of gaps, right? But try to see, feel of those gaps. At some points, there's a lot of research going on. It's called linked data, right? If you apply the linked data, then if somebody knows where you are and how old you are, then somebody can find out your social security number. Although there is no social security number directly attached to your data, but they link one data to another data, link another data to another, and another. Finally, that person can see, oh, this guy might have a social security number from the following 10 or hundreds. So apply all those 100 possible social security numbers to attack, right? That is this iceberg cube. Sometimes you have data. What is iceberg? Only one tenth can see, right? 9/10 under the water. So can you figure out by looking at iceberg only? Entire. We're not going to do this. So what we will do, as I check here, there, association rule, classification, clustering, and this time series, I'm going to work not this association rule, but maybe clustering or classification somewhere there. Okay, this is the types of data. These are the techniques: clustering, classification, association. They're all technique, data mining technique. Time series, there's a characteristics of data themselves. So it's not really the case. Okay, basic concepts of frequent patterns. If you look at this basket, I have 5 baskets. So each basket has ID. We call that TID, transaction ID. And each basket has items to pick up. So basket number 10 has beer, nuts, diaper. Basket number 20, beer, coffee, diaper. 30, beer, diaper, eggs. 40, nuts, eggs, milk. 50, nuts, coffee, diaper, egg, milk. By knowing this, or if we have more data, then we can imagine the weight of their body. Reasonable, right? Reasonable way. By knowing some of the groceries picked up, we can estimate this shopper's is fat or not. That type of things also available, right? But we need more data. So we have item sets. It's a set of one or more item. K item sets means we have K. Okay? If you have 100 item sets, we can say there are 100 elements there. Each element is not necessarily one atomic data. It could be another set. Doesn't matter really. Okay? I have an example. You can find, I can let you know, the website that has been built for the last 30 years. You see Irvine. There is a machine learning lab. And also there is another repository. It's called Knowledge Nugget. Okay, not chicken nuggets, but knowledge nuggets. So there are also a lot of data that can be used for benchmark. And there is a support and support count. Okay? Support, two kinds of supports, absolute support and relative support. Absolute support is the frequency of item set X. Okay. Relative support S is the fraction of transactions that contains X. So it's more probabilities. But they are similar. For example, absolute supports, oh, I need 100 occurrence of these items. 100 out of what? Out of 1,000? Then there is a 10%. If it is the case, then that is relative support. If somebody needs, oh, I want 100 frequency data, then absolute supports. Items of X is frequent if X support is no less than mean soup threshold. So we can assume a minimum support. Okay. The patterns that I hope to mine from my database should be supported by 10% of my database. Then 1 every 10 data items should be applicable to my patterns, right? So if I have such data, then that is useful because every 10 items I might expect this situation. Therefore, I may be able to apply. That's a frequent items sets. Find all the rules. This is called the association rule. X implies Y. With the minimum support, confidence. If you have this rule, then we may think of two things, support and confidence. Support, there's proper probabilities that transaction contains X and Y. Okay? That occurs X, Y. If we have, for example, if you live on the very high altitude, then your academic performance will be good. If you live on very high altitude, then your performance will be, academic performance will be good. Let's say this. By looking at the database, there's all kinds of data sets available, but somebody lives on 100th floor in the city. Somebody lives on 50th floor in the city. Okay. And also somebody lives on, or, in this case, or, somebody is great academic performance. Somebody low academic performance. There's all kinds of mixtures, right? So by counting those, so out of entire database, what's the percentage of having this and this? That is the support. Confidence is once X occurs, how many of them also Y? So by looking at the data about those who live the high floors, And also we look at their academic performance. If their academic performance is also good, then that item is good for confidence. That item gives us confidence. If we have more such data, then we have more confidence. So traditionally, when this idea first developed, 1993, they made two measurements, support and confidence. And after that, a lot of other measurements discovered and used. Okay, so one example here is this. The bottom here, beer implies diaper, and 60% and 100%. Okay, what happens here is that those who buy beer also buy diaper. Those who buy beer, 100% of those who buy beer also buy diapers. That is confidence. Confidence 100. If we say 60%, then 6% of the beer buyer buys diaper. Okay. Another way is that those who buy diaper also buy beer. It's a little less, right? Maximum 75%. So for example, right? I guess this is because those who buy diapers do not drink at all, like for ladies. Those ladies buy diapers, also pregnant, so will never buy beer. Definitely, right? But those who buy beer, like many guys, because requested by kids, definitely buy diaper. Not definitely, if it is the case 100%, or somewhere 100% and 100, 60% and 100. Okay, so association rule formed in this way. X implies Y. If you do X, then Y. So we have support and confidence. The calculation of support and confidence in this way. If X, then Y. What is the supportedness? Then you can calculate. You can count all X and Y in your database, and then the size of your database. So there's a fraction that is the support. Confidence, if X then Y, then we count X. Okay, let's assume X occurs. Only X occurs, then we can consider whether Y also occurs. Y also, in this case, right? Assuming X occurs, then what is the case X and Y also occurs? So this is example. Support how many records that satisfies course equals X and course equals Y, and grade is greater than median 3 times the median, and grade is greater than 2 times mode, or student's status null are in the database. Then we need to count anything that has course equals X, any transaction that has course equals Y, any transactions. Okay. From here, that is all end notation, right? So that should be all, any transactions satisfies all of this, or students is null. We count both of those. And then support can be calculated based upon the entire database. So out of 1,000 transactions, we have 2 students has this, and there are 10 students of this, then that is 12 out of 1,000. That is the support of that. What happens here is that if you say course equals X, and the course equals Y, and the grade is greater than that, and another grade is greater than another mode, then student status is null. We compute that way. Confidence. We count this condition, and among those tuples or transactions, we also need to make sure their student status is null. If so, then that is that needs to be taken into consideration. That's for confidence. So out of this is the entire size in this case. For confidence computation, look at this. Denominator is if part. Whatever satisfies the if part, that is the denominator. Support, the denominator is entire database. Closed patterns and max patterns. A long pattern contains a combinatorial number of subpatterns, combinatorial. But in reality, if you do program, there is, let's say if you have 100 dimensions, 100 attributes, for example, if you know database, 100 dimensions, 100 characteristics, 100 features. So each feature has all different kinds of values. So very complicated. So any pattern described based upon these many attributes is almost impossible. I can show it in the real example. Maybe 2, 3, then all of them are disqualified in terms of supportiveness. Okay. So that is the thing. Closed patterns and max. So, okay. So what we will do, we're going to take a break, but meantime, I want you to download. Not yet. I want you to download the data from this website. If you go to not the fertility, but data sets, then okay, UCI, machine learning repositories. So you can see view all the data sets. What I want, you can take a look this, but the data that I am looking at is fertilities. What's the name of that? Fertility. It doesn't appear here. Fertility. Okay. Then I'm going to look at all of this. Fertility. Okay, this is a fertility data sets. So you can download it, data folder, get it ready, and then that data has these many attributes, but actually 10 attributes. Something about session, season. If there is a number 1 means winter, number 2 spring, number 3 summer, number 4 fall, and age. And then the values are somewhere like this. Oh, wait a minute. Yeah, -1, that is winter. Yeah, it's not number, not that number. Spring, that is a negative 0.33. Summer, positive 0.33. And the fall, positive 1. And then age, at the time of analysis, to see if somewhere in between 18 to 36. So it can give me true, false or true. Childish disease, chicken pox, measles, mumps, polio, so you can have yes or no. And accident or serious trauma, yes or no. Surgical intervention, yes or no. High fever in the last year, then less than 3 months, then negative 1. More than 3 months, then positive 1. So, and then there is 0 in between. And frequency of alcohol consumption, several times a day. Oh, what a great. And also the value for frequency alcohol consumption 0 over 1. Okay, so hardly ever, never, maybe number 1. 0 means several times a day. Smoking habits, never or daily or occasional. Number of hours spent sitting per day, 0 or 1. Output, diagnosis normal or altered, so N or altered. So if you download that, then you can see that data. Data looks like this. Data looks like, here. Yeah, data looks like so this is the data. This is the data. Data that you downloaded does not have a header, right? But my program, what I want you to do also, without this, we do not know what it is, right? So I wanted to have this. So first, this is a CV, comma, separated value, CSV, right? Comma, separated value. So first data before the first comma, that is the season, and next data, that is age, disease, and so on and so forth. So there are 10 data points, each row. How many rows? We have 100 rows. So how many data? 10 times 100, so 1,000 data points. This is a small data, right? It's not really big data. But we can practice this after the break. So during the break, if you come back here early, I want you to download it and get the data ready for you.
Yeah. Just not the other stuff. Just not. Yeah, exactly.
What did you do? You put it in water? So we're gonna put it in.
I would ask you a question, but see them, it's just like, oh my god! It's like, oh god. Oh god.
Evans, yours is recorded here. Your voice.
My voice. No.
Everybody wants. Okay. So we need to, as an example, consider one database that is downloaded from a well-known website. There's a college website, so it's common to everyone. There are many other the real-world data sets available that I introduced to you earlier slides, right? If you look at that. Locally, New York State also publish some data sets that you can use for your projects. Okay. I'm going to remind you to projects. This course requires group projects, right? So please find out your friends to do some of the little greater project among yourselves. The group project can be from non-programming to entire programming. Okay? Which means somebody could do partial programming, mixture of some of the concept learning and developments, and also a little bit of implementations. And for the implementation in programming, it's not necessarily that you need to do from the first phase. First phase means that from data collection phase to the rule generation phases. You do not need to do that, okay? You may do partial also, which means I'm going to do collection parts only. Or I'm going to do, if it is the case of association rule, then I want to count so that data value and frequency. So frequency can be attached to the data. How can you represent that in your memory, in your programming, right? There is a specific algorithm that you need to develop. So with this example, I'm going to help you to do that. What you need to do is that you need to read the files, right? Unless you need to do that manually by paper and pencil, then you need to read the file. So the file should be available in memory of your computer. Then you need to identify columns and rows. Usually it has multiple columns and multiple rows. More rows than columns, right? If we have 10 columns, then 10 columns is still too much. But the example that we downloaded, it has 10 columns. Rows, it has 100 rows, but sometimes it's 1 million rows. And what do we do for identification of columns and rows? So how many occurrences does each value of the attribute exist in the data sets? That is the first thing that you need to do. For each data, how many times does it occur? For each data. That needs to be, that gives you some idea. Right? For example, the data that we looked at, or how many data that's about winter, say -1 for season attributes. Okay. Or if you are interested in smoking habits, then never smoke, -1, or occasionally, 0, or daily, 1, right? So how many of the transactions have daily smokers? So by knowing that, the data with higher frequency and associated with other such data, and eventually the rules to be generated, then such a rule will be will have more supports, which means that rule may occur more frequently than others. If you see the data itself, then you can see it very easily. It's columns and rows. How can you do it in your programs, in your programming? Right? Earlier stage of my data mining research, I was working on database-based data mining. Database-based data mining, then it's not much. It's not really efficient. Database itself is quite efficient, but mining based on tables, which is controlled and managed by database management system, it's not really efficient. And every time anything that you need to do, you need to read it and write it back, and read it, write it back. Then it is a lot slower than all the data available in the memory. Performance-wise, I think thousands of million times slower than working on the memory only. Okay, so if you do the programming, then everything is working on the memory. So as far as you do programming, let's say Python, then you need to think of the structure, data structure. Data structures. Here's the issue. When you develop a data structures, then you need to think of how many attributes, how many values for each attribute. For example, smoking, then we have 3 possible values, right? Number of hours spent sitting per day, how many values? 0 or 1. Sometimes you have 2 values, sometimes you have 4 values, 3 values. Not many values, right? Per attributes. But some other cases, in this particular example, you have multiple attributes, 10 attributes. But there are not many values. There are not many legal values per attribute, because it is already defined. Number 1 means something, 0 means some, -1 means something, maybe 3 or 4 values only. But there are unlimited values possible in some cases. Then such data sets needs to be cleaned out. For example, school you graduate, high school that you graduate. Unlimitedly many, right? We cannot say, oh, we do not know, I mean, who graduated where, right? But all of a sudden in our database, if we have 1,000 patients, then maybe 1,000 different high schools. How many values? 1,000 values. How much? What is the thing that we can learn from there? Not much, right? Because each individual has different data associated with it. Somehow you need to do a little bit of generalize so that it will be the rule. Otherwise it is not the rule. And if you have each every single data has different rules, then occurrence is very, very low, right? If you constitute a rule based upon such data, then it occurs only one time out of like million data. So all the rules have very, very low support, which is not good, right? So you have to do a little bit of a massage it. Let's go back to that high school data problem. What should you do? There are many ways that you can do. You can drop that entire attributes. I'm not going to use a high school information. So remove that column from the table. There's one way. Another way, you can make it categorical data. So that if a high school located in New York City, number 1, New Jersey, number 2, Connecticut, number 3, and so on and so forth, then out of 1,000 different high school data, you may end up having maybe 10. Okay? So that whatever you describe, whatever you mine from such data sets is more meaningful. So that those who graduate from New York high schools has smoking habits, 75%, something like that, right? Rather than saying, those who graduate from Owsley High School has 100% smoking. Accidentally, because our database contains a smoker from Owsley High School. It doesn't make sense, right? The data structures that I've used is somehow a dictionary that you can see in Python. In Python, dictionary is within curly braces. So it is a key and value pair, like a variable and value. It's like this. Like a dictionary. What is a dictionary? You have a word and explanation pair, right? Word and explanation pair. That is the dictionary. If you look up word, then you can see the explanation of that word. You can say annotation of that word. That type of data structures is very, very fundamental data structures. So almost all programming languages built such simple data structures. For example, in Java programmers, what is the language that can handle dictionaries? Map, right? Hash map, hash table, they're all similar. Here in Python, we call that dictionary. And when you enter the elements to the dictionary, it looks like this. For example, if it is college information, say Mercy College, MC. There is a key. There is a pair of college name and number of enrollment. Say 10,000 enrollment, Mercy. Then there is a colon in between key and value. pairs. Okay. I just simplify this. You need to say 1 0 0 0 0, a real number. Okay, and this is a string, MC. MC colon 10,000. There's one pair. Another pair, for example, NYU colon, how many students at NYU? Maybe 18K. And another Harvard. How many students in Harvard? 6K. And so on and so forth. Right? Harvard is 6K, if I remember. There are 1,800 undergraduate students and 6,000 graduate students. And something like that. So what dictionary can do for us, if I want to look up, oh, how many enrollment at Mercy College, then I can say this is my dictionary, say college, call. And if I say call, and then notation is not really, I think there's a square bracket. And then if I say MC, then it returns 10K. If I put here NYU, it returns 18K and things like that, right? If I want to see what are all the keys, then you can say call dot gets. Then it returns gets, and then if you see, no, this is outdated. If you call college and keys, then it returns all the keys. MC, all the keys in list. So it gives you MC, comma, NYU, comma, Harvard. Okay, it returns like this. And if you say call dot values, then it returns only values in the list. 10K, 18K, 6K. So all these dictionary forms can be found in from the Google. So I wanted to find out something from Google. So for you to do that, I can say, for example, Python dictionary. So I have here dictionary, and if you can click any, for example, tutorial points, then doesn't give me. Okay, there are structures here. This is a list, and then maybe somewhere dictionary, right? So you can take a look. Nested list, tuples and sequence, sets, and dictionary here. So this is the dictionary form. Let's say this is a dictionary called telephone. So telephone dictionary has a set of pairs, name and phone number. So if I say tel within square bracket, Guido, then it returns the number if it exists here, right? Something like this. So you can take a look at that if you want. So dictionary is one possible, but it is good to find the other pair if we know one, right? So if we have attributes, then we know the value. We can make that. But what we want in the table is that we want attribute and value and count. So for example, smoking. There's a value 1. How many value 1s in my database? I need to maintain these triple elements as the primitive of my data mining. Primitive. Okay. For example, high school, then value, high school location, value, New York. How many New York-based high schools in my database? There is a count. So I need a triple, not the double, not the pair. So what should we do, right? That type of things is a little bit of implementation techniques. There's no true-false type of implementation. If you choose one in one way, then you may make it efficient, but it's very hard to implement. Meanwhile, the other way maybe is easy to implement, but very low efficiencies and things like that. So there is a complex way and modularity ways. There are a lot of ways, but thing is this is a given data. If you see the data itself, I can bring that data up here. This is data, right? This is data. Data is just like this. Value 1, 1, 1, value 1, 2, and series of those, right? This is a beginning points, and then there is an end point. There's a sequence of those. Only this data has, there is a ending points of each line. So you need to make sure that, there is end points. How can you read the data? See, these 8 data points per transaction. Another data in the next line is another transaction, and so on and so forth. You have to read the data so that data mining can be performed. So another way that I actually did was this. There are many other ways, but by reading this data, I have attribute 1 followed by attribute 1 colon, because this is a dictionary, attribute at 1 colon, this is a dictionary sign, right? Curly brace is a dictionary sign. After the colon, we have a list. This is a sign of a list. This is a sign of dictionary. And in the list, then we need to manipulate. It may occur more than this. We do not fix the number of elements with a list. It depends on your data. Okay. So value 1, how many counts? How many occurrence? Followed by another value, followed by the occurrence of that value, and followed by another value, and another occurrence, another value, and its occurrence, another value, its occurrence, and so on and so forth. So this may be very long or short, depending upon the attribute which has the value. Attribute possible values associated with this attribute is 3, then you may have 3 values with the 3 counts. If you have only 1 value or 2 values, then 1 or 2 of those here, right? This is my structure, but might have another structures possible. So when you see the data, then you need to find out, oh, what data structures that I need to design so that association rule mining will be efficient or inefficient, or easy to implement or hard to implement. Not necessarily easy to implement is always good, because maybe low performance, or if data becomes complex, it may not run. Okay, so complexity of the algorithms may be considered in this way, but that is too much to you. Let's go back. Let's get back to the real algorithm. Okay, algorithm is really needed for all of us. So that algorithm is called the a priori algorithm. Like a diaper, beer, nuts, that type of things. Okay, I wanted to read that. And a priori pruning process is also considered. But I want to look at the real algorithm with an example. That is easy for you to understand. Okay, only thing that we have is a little bigger size than this. Okay, follow this, then you will understand. So I'm going to stop after explaining about this algorithm. Okay, real demo may be on the video. That's very nice. The table that you downloaded is nothing but like this, right? This basket, grocery basket examples, it's not really uniform table, which means first row has 3 columns, second row 3 columns, third row 4 columns, fourth row 2 columns. It's not really uniform. So the table that we want to consider is more standardized. So our data is maybe better, but in real programming, it's not really better, because Python can handle flexibly. It's not really data dependent. So Python can do, same program can do this or that. But in our mind, table form is more standard, so you can consider it more easily. If we have that data, the first step that we need to do is this. Each value, you need to have a count. Support in this case. This support is absolute support. Just count. How many A's appear here in this basket, grocery basket? If you look at the baskets, then basket 1 contains A, basket 3 contains A, only 2 cases, right? So we have the first table that we need to generate has 2 columns, item set and support. If you handle this in database, then you need to create tables. Inefficient. It takes forever, right? Data I/O, input and output, takes forever. Programming Python, then everything is in memory. So quick. So you count each individual data, right? And then there is some condition. Condition is given. We call that a priori. We call that a priori in our algorithm. So a priori means this is something given, right, before we consider. So in general, it's called the a priori data mining algorithm. So what is given? Support. The threshold is given. So absolute threshold is given. Number 2, anything occurs more than 2 times, we accept. It occurs only 1 time, then we drop. So this is drop. we will never consider about data item D in our grocery baskets. For example, from this point, we are not going to consider pizza dough, okay? Because it is rarely picked up. So drop that item. And whatever left, that is A, B, C, D. A, B, C, D, they are all, each data item set contains only one item, right? What is the algorithm of this? What is the data mining? This data mining technique is called not a priori. This is a part of an a priori algorithm. But in general, what is the technique? Remember that in some slides ago, like Mark, right? There's a classification, there's a clustering, and there's one thing. The first technique. What is it called? Association. Remember that I said association.
Did we drop the D because it was the least common?
Yeah, least common, yeah.
So you always do that?
Yeah, based upon this given support. Okay? This is a minimum support. So, we need to now associate. Associate means, currently we have only single item, single data item, right? So we need to associate them. A and B, A and C, A and E, B and C, B and E, C and E. So all possible combinations. From single data items, association is for two items. So data item sets has two sets there. And then we need to go back to the original table, and count how many basket has A and B together. How many of this A and B together? There's no A and B, but here A and B, right? Only one time, so that we have one. How many basket has A and C together? Association. Remember there's association? A and C together. So go back here, and we need to count how many appears A and C together. So basket 10 and basket 30, right? So 2. And A and E, only basket 30. So there's number 1. B and C, basket 20 and basket 30. So twice. B and E here. So B and E occurs basket 20, basket 30, and basket 40. So 3 times. And so on and so forth. Okay? So this is the first time that you associate. Okay? And then count. And if any counts below the minimum support, should be removed from our consideration. So next time we consider only the rest. Okay? And then
how do you determine what's the minimum?
this is given.
Oh.
A priori is a given. So I want to see. I want to.
So anything below the 2?
Correct. Yeah. Below. Yeah. Below 2 in this case, 50%. Out of 4 cases, 2. So I want to mind the rules which can be applicable every other time. There's a 50%, right? It's very high. But anyway, so we have first associated rules, right? Associated data items. So A and C, B and C, B and E, and C and E. Now, what is the next? Next is that we need to combine A, C, B, C together. Then that is A, B, C, right? Another one is B, AC and BC together, AC and BE, then we have 4 data items. So it's no good. AC and CE, then ACE, another item. And CE and BC and BE, then BCE, that is another item. So from here, we can consider A, B, C, right? First and second, and first and third, 4 items. So it is not to be considered at this phase. And the ACE, that is another. And then BCE, that is another thing. Only we consider within this set. BCE and B, this is BCE, same thing. And then third and fourth, that is also BCE, right? Only 3 cases. So that we need to go back. Which basket has A, B, C together? Is there anyone A, B, C? Yeah, there is one case A, B, C. So this one has 1. Anyone has ACE? ACE, ACE, ACE. There is one case ACE. Any basket has BCE. So we have BCE here and BCE here too. For simplicity, this one has only this. But actually should have BCE and ACE. But those 2 are dropped. And finally, we'll have BCE like this. Okay, this is the final steps. What happens then? Every other times, so 50% of our customers can pick up BCE together, right? This is an a priori algorithm. A priori algorithm. This is algorithm description, and this is implementation, and then tools that you can have. We'll do a little bit of this, but real implementation, I'm going to give you a quick demo. Okay, very quick demo, and then we'll stop today. Where is my? Yeah, here. I can say, this is my program, Python, and this is my program, Python Y. This is the data, and my threshold, the minimum support is 0.3, which is 30%. 30%. You can make 50% like this, 0.5, and enter. And I'm going to, very quick, right?
How many lines of code is that?
More line of code. This is given tables. This is a given table. Given table is written in this way. Okay. So minus 0.33, 0.69. 0, 1, 1, 0, 0, 8, 0, 0, 88, 0, 8, 0.88, and then no. So that is in the first element of that list. And the next one is the next element. So that is formed in my data structure. And I want to make sure that input files has 100 records, 400 attributes. I pick up the attributes in like season, age, and I pick up the attributes. And then primitive item sets. This is primitive item sets. Output has output from here. Output is somewhere here, right? The last element. N or O. If output is N, then there are 88 counts for N 12 counts O. If it is a surgical, then 51 has number 1 data, 49 has 0 data. Fever, then 63%, this is a whole 100 records. 63 records has the value 0, and 9 records has value -1, and then 28 records has value 1. If you add all of this, then it's 100, right? And out of this, we need to find out first item set, which is first data item set this. How can you find that? That is the first data item set. Surgical equals 1. We have 51 of those. So out of 100, 51, that is 50% or higher, right? Trauma, value 0, we have 56%. Fever, value 0, 63%. Smoking with the value -1, 56. And so on and so forth. So we pick up only the case of this. And then we need to associate, right? So our association is this. Finally, our association is this. Disease equals 1 and fever equals 0. There are 53 cases. And there is no more. Because this is the maximum. Only 2 values, that is over 50%. Then there is no other 3 values that we can consider. Right? So this type of things implemented. This one takes a couple of days. Whole weekends I spent implementing this. This is not easy, right? So what I want you to do, you don't need to implement all this, but any part, like a reading, or at least primitive item sets, or first item sets, which satisfies the minimum supports. Somehow each one might have different achievement. Okay. This is a way of implementation, but this is using primitive programming languages. But there is another level that we can do using Python module, or if we do this in Excel, that is almost impossible. So many.
Can we do
Remember
it in
that?
Access?
Huh?
Can we do it in Access? Kidding.
That is also too much work. You can try, but too much work. Believe it or not. Remember that table has